are given two functions. The first is f of x equals x to the fourth power plus 2 times x cubed plus x squared. The second is g of x equals negative x squared plus 14x plus k. Now, consider all linear functions of the form y equals 12, x plus a, such that this line stays between the two curves, greater than or equal to g of x, and less than or equal to f of x. In other words, g of x is less than or equal to 12x plus a, which is less than or equal to f of x. We're told that exactly 5 integer values of a satisfy this condition. Our goal is to find the value of k. To begin, we rearrange the inequality. G of x is less than or equal to 12x plus a, and 12x plus a is less than or equal to f of x. We subtract 12x from all parts, which gives g of x minus 12x is less than or equal to a, which is less than or equal to f of x minus 12x. So for each value of x, a must lie between g of x minus 12x and f of x minus 12x. In other words, the number of integer values of a is determined by the vertical distance between f of x minus 12x and g of x minus 12x. One helpful strategy for solving problems like this is to isolate the unknown as much as possible early in the process. Always try to separate the variable you're solving for, so you can clearly see how it relates to the rest of the expression. Let's find where this distance is maximized, or more accurately, where the gap between the two curves allows exactly 5 integers to fit. We start with f of x minus 12x. That's x to the fourth plus 2x cubed plus x squared minus 12x. To find its minimum, we take the derivative. The derivative is 4x cubed plus 6x squared plus 2x minus 12. We set that equal to 0. Trying x equals 1, 4 plus 6 plus 2 minus 12 equals 0. Alternatively, you can solve it using synthetic division as well. So x equals 1 is a critical point. Because all the other terms are always greater than 0, there are no other critical points besides when x equals 1. Plugging back in f of 1 minus 12 equals 1 plus 2 plus 1 minus 12, which is negative 8. So the minimum value of f of x minus 12x is negative 8. Now let's look at g of x minus 12x. That's negative x squared plus 14x minus 12x plus k, which simplifies to negative x squared plus 2x plus k. This is a downward opening parabola. Its maximum occurs at x equals 1. Plug in x equals 1. Negative 1 plus 2 plus k, which equals k plus 1. So, at x equals 1, a lies between k plus 1 and negative 8. We now count how many integers lie between those two values. From k plus 1 up to negative 8 inclusive, we need exactly 5 integers. That means the distance from k plus 1 to negative 8 must be 4. Let's set up the equation. Negative 8 minus the quantity k plus 1 equals 5. Simplify. Negative k minus 8 equals 5. Solving, we find k equals negative 13. Final answer. K equals negative 13.